In this activity, I'm going to show you how we actually derive what's called the sine function and the cosine function. These are graphs that we can actually put on our TI-84 graphing calculator. Because as of now, this unit circle that we're used to seeing, we don't actually graph that on the calculator. So let's highlight one thing. Remember on the unit circle, the x-axis here stands for the cosine movement. The y-axis stands for the sine movement. And for an example, if we were to move, let's say, 30 degrees, which is right here, if that's 30 degrees, I get that it's a degree movement. And when I move 30 degrees, here's the ordered pair. With that, I would get some type of cosine movement and sine movement. So the unit circle gives us the angle movement that takes place and the cosine or sine value. So what we're going to do is have this new graph paper. Above here, you're going to notice that the angle movements have now been transposed here onto the x-axis. And then what's going to be on the y-axis here is actually going to either be the cosine or the sine value. So we're going to start by just looking at here the x-coordinates on the unit circle. And the x-coordinates on the unit circle stand for cosine. So what we're doing is we are trying to derive what the cosine function actually looks like if we were to move it to actual Algebra 2 graphing paper. So here's what we have to do. The directions up here say identify the x-coordinate where each angle intersects the circle in the second graph, and then mark that value for the corresponding angle on the first graph. We're going to do that in 15-degree increments. So if we look at this, you're going to see that this first tick mark is 15 degrees, then 30, then 45, 60, 75, 90, all the way up to 360 degrees, which will be our full circle rotation right here, and then they're going to start over. So here's what the activity has us do again. So we're going to identify the x-coordinate where, let's go to 30 degrees first, where it intersects the circle on the second graph. Now in class, you're going to have a piece of spaghetti. So imagine that this little green line here is my piece of spaghetti. 30 degrees is right here at that dot. And they want to know the x movement. So let me actually highlight the x and the y-axis here. The x movement to get to 30 degrees would be to the right and up. So the x movement is right here. So I want to figure out how to do that x movement. So imagine I have this piece of spaghetti. If I took the x movement, dropped it down right there, can you see that from here to here is the x movement for me to graph this and then go up? So that's my x movement. So what I'm going to do is actually tick mark that x movement on the green piece of spaghetti here. Then I'm going to take this piece of spaghetti that we have right here, and we're going to move it up to here and tick mark its length. So here's what you're seeing is I took this horizontal piece, I then flipped it upward so it's vertical, went to 30 degrees, laid down the piece of spaghetti, and made a tick mark. Okay. Then I'm going to do the same thing. I'm going to come back over here down to the unit circle. Let's go down one. Let's take this and let's measure it for the 15 degrees. So there's my piece of spaghetti, and if I take it and line it up for 15 degrees and I tick mark it here, that's about the x movement for 15 degrees. Let's take that horizontal piece of spaghetti, go up here at 15 degrees and make it vertical, and then label its tick mark, which is right there. You know, we forgot to do 0 degrees, so let's come over here at 0 degrees and do the same thing. So if we do the piece of spaghetti and we line it up and we tick mark this one, which is going to be right here, let's take that spaghetti, now let's make it vertical over here, and what we're going to notice is where the tick mark is going to land on this one is going to be right at 1. So you're going to continue to do this. You're going to do it for all these angles around the circle and then go into quadrant 2, 3, and 4. So continue working on quadrant 1. And then we'll look and see at the results and then talk about quadrant 2. Now, here's what quadrant 1 will start to look like. This curve comes down. Now be careful when we hit quadrant 2. Notice I changed colors on my spaghetti. It's purple this time. All the green pieces of spaghetti are going to the right of the y-axis. This purple one is now going to the left. So I'm going to tick mark it just like I did before. This is right here at 105 degrees. So then I'm going to take that piece of spaghetti and come up here at 105 degrees and line it up. But you have to be careful when you do it, you are tick marking downward this time, because on the unit circle, we're not going to the right anymore, we're now going to the left. So if we do that, we're going to go to the left all the way to 180 degrees, and we're going to continue going left until we get down to 270. So you're going to see this curve come down. So let's continue on with quadrants 2 and 3. So it's going to start to look something like this curve. Now from 270 up to 360, what you're going to see is we're going to start getting positive again. So let's continue on with that quadrant. We're going to get something like this. Now if you connect the dots, here's what you get. This is what one cycle of the cosine graph looks like. Now keep in mind, this is the unit circle of me going from 0 to 360. Can I go around again? I sure can. I can go from 360 to 720. So what happens is this graph that I just drew is going to, right here, is just going to start all over again. This is going to start over and just repeat itself. So if I had to draw it again, it's going to continue on and do something like this in its pattern. Now in the second part of the activity, we're going to do the same thing, but identify the y-coordinate at all 15-degree increments and transpose it up to this graph paper. So let's just see what happens as we start that. If I look first at the 15 degrees, which is right here, the y movement, this is the right, this is the up. So if I tick mark that movement on my spaghetti, I can actually see the up movement. So now I'm going to take this piece of spaghetti and just actually bring it up here at 15 degrees and tick mark where that was at. So then you're going to see our tick mark here. You know, let's actually go back and do 0 degrees. We're going to drop some spaghetti here, and the height to move at 0 degrees, you're going to notice there is no height. I go to the right and I don't go up at all. So the height at 0 degrees is just going to be starting at the origin. Okay. So let's take that and let's go to 30 degrees. So if I move to 30 degrees and tick mark that guy here, and then bring, again, that piece of spaghetti back up here at 30 degrees and tick mark it, we're going to find that we start crawling up the graph a little bit. Now, the highest we're going to reach is when we get here at 90 degrees. At 90 degrees, this thing is going to max out at 1. So what it starts to do, fix that a little, is going to start to go upward. And then the height here, it starts to go down, but the heights are still positive in quadrant 2. The heights don't go negative until we hit quadrant 3, so after 180 degrees. So this graph, we're going to start to see that curvature. Now, the heights are going to max out at negatives. Here at 270, it goes to a -1. So that's where you're going to see this drop down, and then it's going to come back up at 2 pi. So this here is what the sine of theta looks like on graph paper. And again, what we're seeing here, this complete rotation is one movement from 0 to 360. I can go from 360 to 720. I can continue on and graph this again. So I could extend this graph out if I wanted to and continue to draw it.